Last episode, I ended with a question that I haven't been able to shake. I said, if reality is information, what does that mean for death? Is deletion permanent, or is there a recycle bin? And I've been thinking about it a lot. Like, too much. To the point where I'm looking at everyday objects differently. My phone dies, and I think, is that what it's like? I accidentally close a browser tab and panic slightly more than a grown adult should. Because here's the thing. In episode 1, we talked about consciousness having a ceiling. In episode 2, we explored the idea that the Big Bang was a boot sequence and God might be the programmer. But we skipped over something massive, something personal. What happens to you when you die? Not in a religious sense, not in a what do you believe sense, in an informational sense. If you are fundamentally a pattern of information, and physics increasingly suggests that you are, then death isn't a philosophical question. It's not even a biological question. It's a data management question, and that changes everything. Welcome back to the Existence Experiment. I'm your host, Travis R. Barlow. Today we're talking about deletion, preservation, and the possibility that nothing is ever truly gone. Let's get into it. Before we can talk about what happens to you when you die, we need to talk about what you actually are. And I don't mean that in some hand-wavy philosophical way. I mean it literally, physically. What is a human being made of? At the most basic level, you're atoms. Carbon, hydrogen, oxygen, nitrogen, with traces of a few dozen other elements. About 7 octillion atoms, give or take. That's a 7 followed by 27 zeros, which sounds like a lot, and it is, but here's the wild part. None of those atoms are yours. Not really. They were forged in stars billions of years ago. They've been part of rocks, oceans, dinosaurs, trees, other people. Some of your carbon atoms were probably in a T-Rex at some point. Your atoms are on loan from the universe, and the universe is going to want them back. And they cycle through you constantly. Every 7 to 10 years, nearly every atom in your body has been replaced. The you sitting here right now is not physically the same person you were a decade ago. Not a single atom is the same. So if you're not your atoms, what are you? You're the pattern. You're the arrangement. The specific way those atoms are organized, connected, and interacting. Your information. Think of it like a wave in the ocean. The wave isn't made of specific water molecules. Molecules flow in and out constantly. The wave is a pattern that moves through the water. You're the same thing. A pattern that moves through matter. A very, very complicated wave that thinks it's a person. And it's not just your body, your memories, patterns of synaptic connections, your personality, a pattern of neural responses shaped by experience, your sense of self, a recursive pattern, a process that models its own existence. Strip away the atoms, and what's left isn't nothing. What's left is the blueprint, the code, the information. This isn't just philosophy. Modern physics takes this seriously. Information theory, pioneered by Claude Shannon in the 1940s, treats information as a fundamental quantity, like energy or mass. And in the last few decades, physicists have started to argue that information might be the most fundamental thing in the universe. John Archibald Wheeler, the guy who coined the term black hole, famously said, "It from bit." Everything comes from information, every particle, every force field, every interaction. At the bottom of reality, it's not atoms, it's not quarks, it's bits, information. If that's true, then you aren't a body that happens to process information. You are information that happens to be running on a body. Your consciousness, your memories, your personality, these are data structures. Incredibly complex, self-referential, recursive data structures, but data structures nonetheless. And that reframing changes everything about how we think about death, because the question stops being what happens to your body and becomes what happens to your data. Okay, here's where things get really interesting, because there's a principle in physics that most people outside of academia have never heard of, and it changes everything about this conversation. It's called the conservation of information, and it says information cannot be created or destroyed, full stop. In classical physics and in quantum mechanics, information can be transformed, scrambled, redistributed, rearranged, but it can never truly vanish. The universe doesn't allow it. This sounds abstract, so let me make it concrete. Imagine you burn a book. The book is gone, right? Paper, ink, words, all turned to ash and smoke. But here's the thing. If you could track every single particle of that ash, every molecule of smoke, every photon of light and joule of heat released by the fire, you could, in principle, reconstruct the book. All the information is still there. It's just been scattered. The information wasn't destroyed. It was dispersed. scattered across a trillion particles and photons and thermal vibrations. But every single bit of it is still out there, encoded in the state of the universe. This isn't a thought experiment. This is what the math says. The laws of physics are time reversible at the fundamental level. If you could somehow track every particle in the universe and run the equations backward, you could reconstruct that book. You could reconstruct anything. Nothing is truly lost. That's one of the deepest principles in physics, and most people have never heard of it. Now, there's one place where this principle was seriously challenged, and the fight over it became one of the biggest intellectual brawls in modern physics. Black holes. When something falls into a black hole, it crosses the event horizon and gets crushed down into a singularity. All the information about what fell in, its mass, its charge, its quantum state, every detail about what it was, seems to just disappear. In the 1970s, Stephen Hawking dropped a bombshell. He calculated that black holes slowly evaporate over time through what we now call Hawking radiation. And here was the problem. The radiation coming out appeared to carry no information about what went in. It was thermal, random, generic. Which meant, if Hawking was right, black holes actually destroy information. Permanently, irreversibly. This freaked physicists out. Because if information can be destroyed, then the fundamental laws of physics are broken. Quantum mechanics doesn't work anymore. The whole framework collapses. The debate raged for 30 years, Hawking on one side, basically everyone else on the other. And eventually, Hawking conceded. He was wrong. The information is preserved, encoded on the event horizon, the boundary of the black hole, like data etched onto the surface of a hard drive. The information gets scrambled beyond any practical ability to read it, but it's there. It's always there. Think about what that means. Even a black hole, the most destructive thing in the known universe, a region of space-time where the gravitational pull is so strong that not even light can escape. Even that can't destroy information. The universe guards its data with an almost obsessive intensity. Whatever information is, the universe considers it precious, non-negotiable, permanent. If you are information and information can't be destroyed, then what is death? When your body stops functioning, when your heart stops, your neurons stop firing, your cells break down, what's actually happening at the informational level? The pattern that was you isn't being deleted. It's being dispersed, scattered, deconstructed back into the universe's background noise. Like the burned book, the information is still there. In theory, it's just spread across an incomprehensibly vast space. Every chemical reaction of decomposition, every photon of heat, every atom that was once part of your body, they carry traces of the pattern that was you. Death, in information terms, isn't deletion, it's maximum encryption. The data is still there, but the key to read it, the specific arrangement of neurons and chemistry that made it coherent, is gone, at least from our side. You know how sometimes you can't open an old file because you don't have the right software anymore? The file isn't corrupted, the data is fine, you just can't read it. Death might be exactly that, a format incompatibility between the living and the archived. But let's take this one step further, because we're on the existence experiment, and we don't stop at the first interesting thought. If we're in a simulation, and that's the framework we've been exploring, then death might not even be dispersal. It might be something much more deliberate. In computing, when you delete a file, it doesn't actually disappear. The operating system just marks that space as available. The data is still on the hard drive until something else overwrites it. That's why data recovery software works. That's why forensic analysts can pull deleted files off of old computers. Deletion in computing is almost never permanent. So what if dying in a simulation is the same thing? The simulation marks your data as inactive, but doesn't actually erase it. The bits are still on the drive. Your consciousness pattern is still in memory. Every person who has ever lived in this simulation is still in this simulation, sitting in some cosmic recycle bin. Not gone, just not currently running. And what if the recycle bin is what we've been calling the afterlife this whole time? Every religion, every culture, every civilization in human history has had some concept of life after death, some realm where consciousness continues in a different form. Christians call it heaven. Buddhists call it the Bardo. The ancient Egyptians had the Field of Reeds, the Norse had Valhalla. Across thousands of years and thousands of cultures, the same core idea: death is not the end. You go somewhere else. What if they were all describing the same thing? Not a mystical realm, not a spiritual plane, a data archive, a partition of the simulation where inactive consciousness patterns are stored, and every culture, through its own lens, caught a glimpse of it. I know what you're thinking. Okay, this is a fun mental exercise, but is there any actual reason to think this is more than a metaphor? Well, let's look at something that's been documented for centuries but has only recently gotten serious scientific attention: near death experiences. About 10 to 20% of people who are resuscitated from cardiac arrest report some kind of NDE, tunnels of light, overwhelming feelings of peace and love, life reviews where they see their entire history play back like a movie, encounters with deceased relatives, out of body experiences where they can describe things happening in the room that they shouldn't have been able to see because they were clinically dead at the time. Now, the standard scientific explanation is that these are the brain's response to oxygen deprivation, neurons firing chaotically as systems shut down, endorphins flooding the brain, the temporal lobe going haywire, and that's a perfectly reasonable explanation. I'm not dismissing it. But look at it through the information lens. If consciousness is a data process running on biological hardware, then a near-death experience looks remarkably like what happens when a program is being shut down but hasn't fully terminated yet. The life review, your whole life flashing before your eyes, that's a memory dump. The system flushing its cache before shutdown. Every major file getting one final read before the drive goes offline. The tunnel of light? A rendering artifact. The visual processing system powering down. The peripheral vision going first, leaving a narrowing circle of light in the center. The overwhelming feeling of peace? Error suppression? The system turning off its alarm signals, pain, fear, anxiety, as it transitions to an inactive state. No need to panic the user during a controlled shutdown. The encounter with deceased relatives? Maybe the system is establishing a connection to the archive, pinging other entries in the recycle bin. Here's where you're going. Here's who's already there. I'm not saying NDEs prove the recycle bin, but they're consistent with it. They look like what you'd expect if consciousness were a program going through an orderly shutdown sequence rather than a random crash. Here's another piece of the puzzle that I find fascinating: quantum entanglement. When two particles interact and become entangled, they share a connection that persists regardless of distance. Measure one particle in New York, and you instantly know something about the other one, even if it's sitting in a lab on the other side of the planet or the other side of the universe. The connection is instantaneous. It doesn't travel through space. It's just there. Einstein hated this. He called it spooky action at a distance because it seemed to violate everything he believed about locality and causation. But he was wrong to doubt it. Quantum entanglement has been experimentally confirmed thousands of times. It's real, it's proven, it's one of the most thoroughly tested phenomena in all of physics. Now think about what this means for you. Your body is made of particles that have been interacting with other particles since the moment the universe began. You are quantum mechanically entangled with basically everything. Every person you've ever touched, every breath you've taken, and by extension, every person who breathed that air before you. Every photon of sunlight that's hit your skin carries a connection to the star that produced it. These connections don't end when you die. Entanglement doesn't care about biology. It doesn't care about heartbeats or brain activity. The quantum correlations persist. They're woven into the fabric of space-time itself. What if those persistent connections are how the simulation maintains links between active and inactive data? What if the reason people sometimes feel the presence of someone who's died isn't wishful thinking? It's a real informational echo, a trace of entanglement still resonating? I'm speculating, obviously, but the entanglement is real. The connections are real. Whether they carry something we'd recognize as presence, that's the part we can't test. Yet. All right, you know the drill by now. 3 episodes in, this is our thing. I say something wild and then I try to tear it apart before you can. The biggest problem is the practical one. Yes, information is conserved in principle, but in principle is doing a lot of heavy lifting there. The information from a burned book is technically recoverable, but you'd need to track every single particle in the universe to do it. That's not just hard, it's functionally impossible for any entity inside the system. Conservation of information is a law of physics, but it doesn't guarantee the information is accessible. There's a huge difference between still exists somewhere in the universe and can actually be recovered and made coherent again. Your data might technically be in the recycle bin, but if nobody has the password, if no one knows how to reassemble the scrambled pieces, does it actually matter? The counter-argument, and the reason I still find this compelling, is that we're talking about a simulation run by something outside the system. The programmer doesn't have our limitations. From outside, recovering dispersed information might be trivial, like a sysadmin restoring from a backup. We can't do it from inside the simulation, but whoever's running it absolutely could. The other pushback, correlation isn't causation. NDEs looking like system shutdowns doesn't mean they are system shutdowns. The brain is weird. Oxygen deprivation makes it do strange things. Fair. But here's what I'd say to that. When you have a framework that explains the ceiling of consciousness, the boot sequence of the universe, the fine-tuned constants, and the nature of death, all in one coherent model, at some point you have to ask, is this really all just coincidence? Or is the pattern telling us something? I don't know, but I think the question is worth asking out loud. Here's the thing about this idea. It's simultaneously the most comforting and the most terrifying possibility I can imagine. Comforting, because it means nothing is truly lost. Every person who has ever lived, every consciousness that has ever flickered into existence, every laugh and heartbreak and quiet Tuesday afternoon, the information is still out there, somewhere. Your grandmother, your childhood dog, that version of yourself at age 6 who believed the world was magic and monsters lived under the bed. None of it is gone. It's just filed away, stored in a part of the system you can't access from here. But it's also terrifying, because if consciousness can be stored, it raises questions about what stored consciousness experiences. Is it like sleep, dreamless, timeless nothing? Or is it like dreaming, some half-lit version of awareness, running in low-power mode? Is it aware? Is it waiting? The idea of a cosmic recycle bin is only comforting if the data inside it isn't suffering, and we have absolutely no way of knowing what that state is like from the inside. That's the part that keeps me up at night. But here's what I keep coming back to. Whether you believe in the simulation or the recycle bin or any of this, the physics is clear. Information is conserved. The pattern that is you will, in some form, persist. The atoms will scatter. The energy will dissipate. But the information, the fact that you existed, the specific way you existed, the exact configuration of matter and energy that was you, that leaves a mark on the universe that cannot be undone. You are a permanent entry in the universe's ledger, and no amount of time, no amount of entropy, no force in any reality can erase that. And I think there's something deeply, fundamentally important about that, not as a theory, as a way of being alive. If you know, really know, that what you do leaves an indelible mark on the fabric of reality itself, doesn't that change how you show up? Doesn't that make every interaction, every kindness, every moment of genuine connection feel a little more weighty, a little more permanent? Maybe that's the point. Maybe the simulation, if that's what this is, isn't just running to see what happens. Maybe it's running to record what happens, and we're the story it's writing. That's episode 3 of the existence experiment. We went from atoms to information theory to black holes to the cosmic recycle bin, just another day at the office. Let me tie all 3 episodes together because they're building towards something. Episode 1. Consciousness has a ceiling, a hard limit on what any intelligence can understand. Episode 2. The universe might be a simulation, the Big Bang a boot sequence, God the programmer. And now episode 3. If that's true, death isn't deletion, it's archival. The pattern that is, you doesn't disappear when you die. It gets filed away, stored, preserved in the universe's memory, whether that memory belongs to physics or to a programmer. Next episode, I want to explore something that fell out of today's conversation. If consciousness is a pattern, and patterns can be copied, what does that mean for identity? Are you the only you, or are there backups running somewhere you don't know about? That one's going to mess with your head. If you liked this, share it with someone who overthinks everything, leave a review, and if you've had a near-death experience and want to share your story, send it to me. I'd love to hear it. I'm your host, Travis R. Barlow. This has been the Existence Experiment, and remember, if you're in the recycle bin, at least you haven't been overwritten yet.